Okay. Now we just see the state transition matrix is one of the question. Okay. There may be he may ask state transition matrix, and in that state transition matrix, just now I just write some properties of state transition matrix. Pi of t, which is equal to e power at. Now see here, if I take pi of t1 plus t2, which is nothing but e power a into t1 plus t2. So we can write like this, e power a into t1 into e power a into t2. So this we can write like this, right? Now this is pi of, what is this? This is pi of t1 and this is pi of t2. That's what I am writing, one of the property, pi of t1 plus t2. This is pi of t1 plus t2, which is equal to pi of t1 into pi of t2. Is it right or not? Okay. This is pi of t1 plus t2, which is nothing but pi of t1 into pi of t2. And e power at whole power minus 1. So I can write like this, e power minus at. So e power at is nothing but, this is pi of t whole power minus 1. This is nothing but pi of t means e power plus at. Now this is pi of minus t. This is another property. Okay. And this is e power at whole power k, which is equal to e power a k t. Now this is pi of t whole power k, which is nothing but pi of kt. These are the properties of the state transition matrix proofs. Okay. And you know that pi of 0 is identity matrix, which we already proved. Okay. Okay. So we already covered the solution of state equation under homogeneous condition. This is the solution of state equation under homogeneous condition. Now we will see the non-homogeneous condition. Non-homogeneous solution. The non-homogeneous solution is, now means we have to kept u of t is not equal to 0 now. U of t is not equal to 0. U of t is not equal to 0. Now what is the first equation? Dx of t by dt, which is equal to a into x of t plus b into u of t. Apply Laplace transformation. Then if we apply Laplace transformation, so s into x of s minus x of 0, which is equal to a into x of s plus b into u of s. Therefore, if I take x of s as a common, si minus a, which is equal to x of 0 plus b into u of s. X of s, which is equal to si minus a matrix inverse into x of 0 plus si minus a matrix inverse into b into u of s. Now if I apply inverse Laplace transformation, inverse Laplace transformation of x of s is x of t, which is equal to, this is inverse Laplace transformation of si minus a matrix inverse into x of 0 plus, this is inverse Laplace transformation of si minus a matrix inverse into b into u of s. So can you see this is somewhere? Now this is the state equation solution under homogeneous condition without initial condition. Okay. Now this is See here B is coming because you are taking input, right? Now here B is not there, means your input is 0. Means now this is nothing but, this is called as 0 input response. Now before we do the derivation part of this, I am explaining one complete detailed table. This is a 0 input response, okay, and this is 0 state, means we are not take the output equation, only state. This is 0 state response. This is the 0 state response. Now this is the 0 state response due to input. Here input is used, B is used. This is 0 input response due to input. This is 0 input response due to initial condition. Due to initial condition. This 0 input response is due to initial condition. This is 0 state response due to input. Okay. Now this is due to initial condition. This is due to response. Complete response, if he is asking, what is the complete response? Now what is the complete response? Output. Okay. Response is nothing but output. Complete time response. Sometimes he is asking the question like this. Complete time response. What is the complete time response? Y of t, which is equal to C into X of t plus D into U of t. Most of the time the D is not there. So if it is there, you can print. Otherwise, Y of t, which is equal to C into X of t. Therefore, now what is X of t actually? Now the solution of state equation X of t, which is nothing but 0 input response plus 0 state response. This is the X of t. So what is the complete time response Y of t? The complete time response Y of t, which is equal to C into X of t. What is X of t? 0 input response plus 0 state response. Now this is Y of t. That is a complete time response. If he is asking complete time response, now this you have to do it. Okay. Now if you want to do this, first you want to know 0 input response is due to initial condition. X of 0 is given. So substitute here. Now this part, if you see here, now in this 0 input response, now without initial condition, this matrix is called as, without this initial condition, this matrix is named as state transition matrix, which means that this is pi of t or e power at into X of 0. Now this is pi of t into b into u of x. Okay, no doubt. Clear or not? Now this is the 0 input response, this is the 0 state response. Then he is not asking to find 0 input response, 0 state response. He is asking only complete time response. So you have to be identified. This is the complete time response. See here. This is complete time response. When this is the complete time response when input is given. Because if input is there, then only this 0 state response is coming. No, you tell me now y of t, which is equal to c into only 0 input response. Okay, c into only 0 input response. Then there is no 0 state response. When there is no 0 state response, tell me if input is not there. If u of t is not there, u of t is not given, u of t is not there means b is also not there. So this is 0, this is not there. So this is the complete time response. This is the complete time response when there is no input. When input is not available. So see the question, whether the input is present or not, you decided, then you want to calculate this or you want to calculate this, you can decide. Okay. Now this is one question which is nothing but solution of state equation is nothing but a complete time response is one important question. Okay. Now we will therefore now the question is, now this is one question, complete time response. Now this is one question, what is how to find the complete time response. Okay, we'll solve question. Determine the complete time response. Determine the complete time response. Question is, determine the complete time response by considering the following state space model. Now, this is the complete time response by considering the following state space model, by considering the following system, determine the complete time response. Then immediately in your mind you want to have some idea. See here, this is dx of t by dt, which is nothing but a into x plus b into u. Where is b? Where is u? No b, no u. Am I or not? Now this is b into u. This is b into u of t. But in this particular question, there is no b, there is no u. Which means that when b is not there, when u is not there, input is not available. When input is not available, then the complete time response equal to c into 0 input response. Understand not? Now the complete time response equal to c into only 0 input response. Now in this situation, so the complete time response is nothing but 0 c into 0 input response. Now first we want to find a 0 input response. Like that you can first have an idea. So y of t, which is nothing but c into 0 input response, is the final complete time response. Okay. So that is the complete time response because when input is not available here. So now first what should we do? 0 input response. You find first 0 input response. What is the 0 input response? The 0 input response is SI. 0 input response is nothing but inverse Laplace transformation of SI minus A matrix inverse into x of 0. Right? Now this is which is nothing but first you want to find SI minus A. Right? Now what is SI minus A? First you should find SI minus A. S0 0 S minus A 0 1 minus 2 0. Therefore which is equal to S minus 1 plus 2 S. S minus 1 plus 2 S. This is SI minus A matrix. Now this is SI minus A matrix. Now I want Si minus A matrix inverse. So first you should find adjoint of Si minus A matrix. What is adjoint? Diagonal element position is changing and opposite diagonal element sign is changes. And determinant of Si minus A, which is equal to AD minus BC, A square plus B square. Now, what is Si minus A matrix inverse? Si minus A matrix inverse, which is equal to adjoint of Si minus A by determinant of Si minus A, which is equal to S by S square plus 2, 1 by S square plus 2 minus 2 by S square plus 2 S by S square plus 2. This is finally Si minus A matrix inverse. Therefore, whose inverse Laplace transformation? What is zero input response? Zero input response is now inverse Laplace transformation of that. Now see here, S by S square plus B square. So here we can write like this. Inverse Laplace transformation of S by S square plus B square means root 2 whole square. Now this is B by, now this is root 2 by S square plus root 2 whole square. B by S square plus B square. Now here is also minus 1 by root 2 and root 2 by S square plus root 2 whole square. So now root 2 cancel, minus 1 here, but here it is already 2 is available, so you can take it as root 2. So now root 2 into root 2 is a 2 is sufficient. Okay. Now this is again S by S square plus, so S by S square plus root 2 whole square. Now this is Si inverse Laplace transformation. This is the inverse Laplace transformation of, this is a zero input response. Now what is the zero input response? This is the zero input response. Now the zero input response, which is nothing but inverse Laplace transformation of this. Now this is cos root 2t. Now this is 1 by root 2 into sin root t, b by s square plus b square. This is minus root 2 into b by s square plus b square sin root 2 into t, s by s square plus b square cos root 2 into t. Now this is zero input response. Okay. Now there is a zero input response. Now what is the complete time response? Now this is the complete time response. Now the complete time response y of t, which is equal, this is multiplied with, zero input response is, this is multiplied with x of 0. What is x of 0? X of 0 is nothing but 1, 1, 1, 1. So this is a multiplication. This is 2 by 2 matrix. This is 2 by 1 matrix. Okay. So now the zero input response is completely zero input response, which is nothing but now 2 cancel, 2 rows and only 1 column. Now see here, cos root 2t plus 1 by root 2 into sine root 2 into t. Now minus root sine root 2t plus cos root 2 into t. This is the zero input response. This is the zero input response. Now, after writing the zero input response, now what is the complete time response? Now the complete time response is y of t which is equal to c into zero input response. Now what is c? C is nothing but 1 minus 1. This is c into zero input response. What is the zero input response? This is the zero input response. Cos root 2t plus 1 by root 2 into sine root 2 into t. Now minus root 2 into sine root t plus cos root 2 into t. Now this is 1 by 2, this is 2 by 1. So now the answer is only 1 by 1. Therefore, the complete time response y of t, which is nothing but, now this is cos root 2t plus 1 by root 2 sine root 2t minus root 2 sine root t plus cos root 2. Now this is cos root 2t plus 1 by root 2 sin t. Now this is minus minus plus root 2 sin root 2t. Now plus into minus minus cos root 2t. Cos root 2t minus cos root 2t cancel. Now this is root 2 can now sin root t is, if you take it as a common, 2 plus 1 3 by root 2. Therefore the complete time response y of t, which is equal to 3 by root 2 into sine root 2t. This is the complete time response. Okay, note down this. This portion is for only Si minus A matrix inverse portion. I can write separately. Okay. Clear or not? Okay. Now this is the complete time response when input is not given. Okay. Now we'll solve one more question. Now see here. Now question is, determine again complete time response by following the state space model is given. Now this is the state space model which is given, plus 0 5 into u, where x of 0 is 1 0 and y is 0 1 into x. Now he is asking the complete time response. Okay, what is asking? Complete time response, and this is the question. Now when he asking the complete time response, but now you see here there is a B is present, means now input is available. When input is available, what is the complete time response? The complete time response is nothing but, I'm already mentioning, the complete time response is nothing but C into 0 input response plus 0 state response. Then we will solve one by one. Okay. Now first we will see the 0 input response. Now next we will see the 0 state response. Now see here, what is 0 input response? Now first 0 input response is Si minus A. This is the 0 input response. Si minus A inverse into x of 0. What is Si minus A? Now this is A is 0, 1, minus 2, 0. Okay, right? Same. This is same, Si minus A. This is the joint. Now therefore this is nothing but Si minus A. Oh, sorry. This is 0, 1, minus 2, minus 3. This is, sorry, minus 3. So now there is a small change, right? Now 0, 1, minus 2, minus 3. So this is, okay, this is S plus 3. So now the adjoint is S plus 3, and this diagonal element is changing, and opposite diagonal element sign is changing. S plus 3, 1. Now this is plus 2, 0, 1, minus 2, minus 3, 0, 5, 1, 0, 0, 1. Okay. Now this is S plus 3, 1, S minus 0, 0 minus, this is plus 1. S minus 0, S 0 minus 1, minus 1, 0 minus, this is plus 2, and S minus minus S plus 3. This is Si minus A matrix. What is adjoint? Adjoint is nothing but diagonal element position is changing. S plus 3 is here. S is here. Opposite diagonal element sign is changing. 1 minus 2. Right. Now, determinant of Si minus A. Now, S into S plus 3 plus 2. S into S plus 3 plus 2. S square, which is nothing but S square plus 3S plus 2. S square plus 3S plus 2 means the roots are S plus 1 into S plus 3. Oh, sorry. S plus 2, right? S square 2 plus 1, 3, 2 into, right? Matching. So Si minus A matrix inverse. Now the Si minus A matrix inverse is, Si minus A matrix inverse is adjoint. Adjoint is nothing but S plus 3 by S plus 1 into S plus 2. Now 1 by S plus 1 into S plus 2 by minus 2 by S plus 1 into S plus 2. Now S by S plus 1 into S plus 2. Now this is Si minus A matrix inverse. Now see here. Now this is Si minus A matrix inverse multiplied with x of 0. Now which is nothing but, now S plus 3 by s plus 1 into s plus 2, 1 divided by s plus 1 into s plus 2, minus 2 divided by s plus 1 into s plus 2. Now s divided by s plus 1 into s plus 2 multiplied with x of 0. Now x of 0 is nothing but 1, 0. So now this is 0 input response finally. Now this is 2 by 2, this is 2 by 1. Now therefore, which is nothing but, now this is 0. So finally s plus 3 by s plus 1 into s plus 2, s plus 2. Now minus 2 by s plus 1 into s plus 2. So this is the 0 input response. Okay. Now this is 0 input response and inverse Laplace transformation of this. What is the inverse Laplace transformation? So the inverse Laplace transformation of this is, first you want to do the inverse Laplace transformation. Now this is Si minus A matrix and this is Si minus A matrix inverse, and these inverse Laplace transformation. Now after that you want to multiply it with this. So now see here, this is Si minus A matrix inverse. Then this inverse Laplace transformation is, then after that you multiply it with x of 0. Then this inverse Laplace transformation, what we are getting here is, the inverse Laplace transformation of this answer I will write directly. After doing the partial fractions, now this is 2 by s plus 1 minus 1 by s plus 2, 1 by s plus 1 minus 1 by s plus 2, minus 2 by s plus 1 plus 2 by s plus 2, minus 1 by s plus 1 plus 2 by s plus 2. This is after doing the partial fraction. Then you apply the inverse Laplace transformation. What is inverse Laplace transformation? Now this is nothing but 2 into e power t minus e power minus 2t. Now this is e power t minus e power minus 2t. Now this is minus 2 into e power minus t plus 2 into e power minus 2t. Now minus e power minus t plus 2 into e power minus 2t. Now this is Si minus A matrix inverse. This is Si minus A matrix inverse and whose inverse Laplace transformation. Now this you just simply multiplied with x of 0. Okay, note down this.